Okay, I think I fixed it. Sorry for the audio glitch there. Tell me if you can hear me. Um, I think I fixed it. I went into settings. Again, this is all still this is the fourth time that we've ever done this. So hopefully what I just did the fix. I ran a couple of tests before I tried popping up here. Apparently that didn't work. So hopefully here everyone is loud and clear, says Candace Johnson. Woohoo! We are up and running. Let's learn about some clouds. I am very excited to talk to you guys about the different kinds of clouds that we see in our atmosphere. And sweet, loud and clear, can hear me? Good. All right, audio is fixed. All right, something in settings. You know how it is. Anyway, let's take a look at, look at all this. There's so many pictures here, so many different kinds of clouds out there. You might be wondering how we tell them apart, all this kind of stuff, what the different names are. So we're going to go over some of the basic ones, but we're also going to take a look at some of the more unique kind of clouds as well. And so the first thing that we're going to talk about is, well, let's take a look at some cloud facts. So clouds are formed when water vapor condenses into water droplets. Sometimes there's a lot of water vapor in the atmosphere. Sometimes here in West Texas, we all know that there is not. But you can't see water vapor, but once the temperature cools down to the dew point, that water vapor will condense, and it'll condense into a cloud. But it also, fun fact, it actually needs something to condense onto. So it needs some dust, which we have plenty of here in West Texas, or salt particles, especially near the ocean. So water droplets can't just form on nothing. They need something to kind of stick onto. Now, if you could weigh a cloud, a cumulonimbus cloud, which we'll talk about in a second, but basically those are your thunderstorm kinds of clouds, that would weigh about as much as 400,000 pounds. That's a lot. That's the same there as an Airbus A380, which is the largest aircraft in the world, or largest airplane, I should say, in the world. And at any given time around the Earth, it's covered, 67% of it is covered in clouds. So clouds are a huge deal and a huge driver when it comes to our weather. So yeah, let's learn about some of the different kinds that we can see and which ones are most common here in West Texas. Let's check the comments here, just to make sure none of y'all got any questions. Kenda says it's funny that clouds are so heavy. Isn't that kind of interesting? But if you think about it, they're stretching so far up into the atmosphere. That's a lot of water that you're trying to weigh. So these are some of the high clouds that you might see. You've got your cirrus clouds. Those are kind of the horsetail clouds that you see way up there in the atmosphere. These are mostly going to be made of ice. In fact, they're almost all completely ice. That's kind of why they have sort of a hazy appearance. Cirrostratus, we saw a couple of those up there today. It's one of the kinds of clouds that we saw out there today, and those are just some high clouds that have formed more of a layer. The word stratus comes from the word layer. I believe that's Latin. Yeah, I'm pretty sure that's Latin. And so stratus means layer, and so that's kind of when you get more of that layering of those cirrus clouds. And cirrocumulus, those are kind of those poofy ones that you see way up there. And sometimes these are the ones that are kind of the hardest to really tell apart from a couple of the next clouds that we're going to see. So those are the high clouds. Let's talk about the middle clouds. And right away, you see that these ones, how do I know that these altocumulus clouds aren't cirrus clouds? And typically what you can do is with altocumulus clouds, if you take your fingernail and kind of hold it up to the sky, altocumulus clouds tend to be this kind of that size, especially if they're in this more poofy form. If it's in this form right here where it's kind of more in straight lines, it's a little harder to tell, but you usually don't get these kind of straight lines with cirrus clouds. And so if you're looking at these altocumulus, they're kind of poofy. If they're about the same size as your thumbnail, that's how you know they're alto instead of high clouds, which are cirrus clouds. Those ones will be a little bit smaller. Now, another thing you can also see is altostratus. Again, just a layer of clouds there in the mid layers of the atmosphere. And of course, we have our low clouds, and stratus is going to be, they're really kind of boring to look at. They're those gray clouds that kind of form if we have a foggy morning and then we see the fog lift. Whether that term is accurate or not is a story for another time. Once that fog starts to clear out, you're still left with that kind of layer of clouds. Those are your stratus clouds. And another thing, of course, if you get rain with stratus clouds, that's when you get nimbostratus. Nimbo means rain, and that's where cumulonimbus comes from as well. And of course, here you have your cumulus clouds, which we see a lot here in the spring and summer, those puffy clouds that are pretty close to the Earth's surface, maybe just 1,000 to 2,000 feet above the surface. So those are the low clouds. Sue says she didn't know about clouds needing dust or salt to form. Yeah, isn't that kind of interesting? I didn't know about that either. But yeah, it turns out that water vapor needs something to kind of stick to when it condenses. So kind of interesting there. Luis and Catherine says, grandkids enjoy this for home. Thank you. Thank you so much for tuning in. Again, sorry about if you were watching at the beginning, the audio issues. Some weird setting, but you know, that's how things go. Now these are the vertical clouds. The vertical clouds are the exciting clouds. They're the storm makers. They're the ones that produce all the hail, all the rain, all the wind here in the spring and summer. And so for starters, you have your cumulonimbus clouds, and that means it's just a cumulus cloud that's basically gotten tall enough to start producing rain. Now, one thing that's cool about cumulonimbus clouds is oftentimes all the weather in the atmosphere occurs in what's called the troposphere. That's the lowest layer of the atmosphere, and that's a layer where the tendency is that temperature decreases with height. But once you get up to the stratosphere, things become a little bit more stable, so temperatures increase with height. So the clouds basically run out of energy available to them to keep going up, and so what they do is they kind of pancake out, and you get what's called an anvil at the top of that cumulonimbus cloud. So a lot of times you start to see these when we start to see thunderstorms forming here in West Texas, and you get that nice flat anvil at the top of that cloud. So something kind of interesting to look out for as we go into the spring and the summer. And of course, the mother of all clouds, the supercell. Now, the supercell is in itself a cumulonimbus cloud. The thing that sets a supercell apart is that it is rotating, and you can sometimes notice that. You see how there's kind of these striations. It's very, very smooth in the lower layers, and then once you get out here, that's getting higher up in the cloud, it's a little more poofy. So that's really, and you can really tell the difference between this cumulonimbus cloud. There's not a lot of smoothness near the bottom of that cloud. Supercells tend to be very, very smooth near the bottom, and you can often, because of that smoothness, actually see the rotation inside that cloud, and these are the supercells that go on to produce, that can produce tornadoes. Now let's get into some more maybe less common clouds that sometimes we don't even see here in West Texas. In fact, I bet you this one right here, this is my favorite cloud actually, is a lenticular cloud, and this is from Washington State over Mount Rainier. Had to throw them into this one, and you can see it's kind of shaped like a little bit of a lens or a UFO. Now, we can get these here in West Texas, but they're pretty rare. They usually like to form over mountains like you see here, or just downstream of a mountain. And that's because basically once you have air running into a mountain, it's forced to go up and down as it goes and encounters that mountain. And so if you get that air going up, it can cool and condense and form this awesome shaped cloud. So that's my favorite kind of cloud. Let me know in the comments here what your favorite kind of cloud is, or once we get to the end here, I'd like to see what your guys' favorites are. Now, these are mammatus clouds, and we see these here in West Texas. We saw a good amount actually last spring, and what this is actually, it is cold air that's up in the thunderstorm trying to come back down, and it forms these sort of pillowy kind of, they look like, they get the name actually because they look like a cow's udder. I don't know who decided to name them after that, but That's what the mammatus clouds are named after, and it's just that cool air that's kind of trying to billow out of the thunderstorm. You usually see these on the backside of a thunderstorm after the storm has passed. Kelvin-Helmholtz clouds, these ones are kind of cool, and we can actually see them sometimes here in West Texas, although they are very rare. And these ones are associated with different wind speeds at different levels of the atmosphere, changing very quickly. So if you have winds that are traveling, very slow in one layer, but maybe go up a few hundred, maybe to 1,000 feet, and they're traveling very fast, you can get it's almost like a wave breaking in the ocean when you have that water that's closest to the sand being slowed down more than the water at the surface of the ocean. And that's why those waves break when they collide into a beach. This is kind of the same thing here happening in the atmosphere. And it just has to do with the different speeds in the different layer of clouds. So those are something pretty rare here in West Texas, but I have seen them once, so keep your eyes peeled for those. And of course, we have contrails, not chemtrails. These are actually, and no conspiracy theorists allowed here, these are actually real and produced by airplanes, and it has to do with combustion. The air that comes out of an airplane's engine is so warm that when it cools, it can condense and form these contrails up in the atmosphere. And this is usually, this can be a sign sometimes that maybe the atmosphere is priming itself for us to see some rain. But here in West Texas, that kind of analog doesn't really work. It works in some parts of the country more than others. What you're really seeing is that there's just an area in the high levels of the atmosphere that have a little bit more water vapor. So when you get that hot exhaust coming out the jet engine, it'll cool, condense into a nice little trail behind that airplane. So it's not the government spraying chemicals into our atmosphere. It's a cool kind of science physics phenomena. Now I got one more slide here for you, Unique Clouds Part 2. And if you remember, let's start with this one in the middle here. This was a time lapse sent in by one of our viewers of a shelf cloud. Now, sometimes shelf clouds can be attached to a thunderstorm. Other times they can shoot out from a thunderstorm with that cold air that's sinking down and it's spreading out in front of the thunderstorm. That's what you're seeing here. This is some cool air that's surging out ahead of that thunderstorm, and a cloud formed on that leading edge. And so this is what we call a shelf cloud, and you can really tell these ones apart pretty quickly, especially if they're like that just out ahead of the approaching thunderstorm. So kind of cool video there. Another cool one that's a lot of new research going into these ones, actually, pyrocumulus clouds. And you notice all this smoke here. This is actually from the Australian wildfires back in January, and it's because the air from these fires gets so hot that it has a lot of energy as it goes up into the atmosphere, and so it's able to go even higher than it would if there wasn't a fire. And so it's actually able to go high enough where once the temperature cools, it reaches the dew point and is able to condense into a cloud. So what you're seeing here are pyrocumulus clouds, which it's basically just like summertime thunderstorms, except the heat isn't coming from the sun, it's coming from the fires down on the ground. So kind of interesting to see those. We've seen them in Alaska, Washington State, California, where we've had some of the wildfires in the past couple of years, and most recently in Australia. And of course, we have funnel clouds, which can end up turning into a tornado if that cloud reaches all the way down to the surface. Funnel clouds are a spinning column of air, and when you get that rotation, it's inherently you get an area of lower pressure there right at the center of that cloud. And so the lower pressure actually corresponds to a slight decrease in temperature, and that can get it down to the dew point, causing the air in the water vapor in the atmosphere to condense, and that's why you get funnels, and that's why you can see a tornado. And of course, it has to make it all the way down to the ground to be a tornado. So let's see if we've got any questions here. Sue is actually the one who recommended this. I should have said that right off the top of the video, but Sue was the one who wanted to talk about the different kinds of clouds that we can see and how to pick them apart. So thank you, Sue, for recommending this. Remember, if you want to recommend something, if you want to, you know, have something that you want to see here as part of our science classes, our StormTracker 9 science classes, let me know. Send me a message, send a message to News West 9, drop a comment here on this Facebook Live, and we're going to try and get to as many of these as we can. I'm pretty excited for where this is going. Again, audio issues, I think I have that resolved now. There's just a setting in this software that we're using that I have to make sure that I click every time. Kind of annoying, but it is what it is. So I hope you guys enjoyed that, learned something about some clouds that we can see here in West Texas and ones that we don't often see, if at all, here in West Texas. And yeah, I hope you guys are continuing to stay safe, continuing to social distance. I'm really excited to bring you guys more of these science lessons. So yeah, just let me know what y'all want to see. Thank you again for tuning in, and I'll see you guys next time.